In this video, we are going to solve this question I have on the screen here, which says that we should use the method of join to determine the force supported by each of the member of the truss shown. Okay, so we are going to use the method of join to determine what the force supported by what each of the members of this truss system was shown here. Okay, so what that means is that you should calculate the force in each of these truss members. Okay, so these are the truss members. These are the truss members. These are the truss members. So we are going to find what the force in each one of them. Okay, so for this to be easy for us, first of all, we are going to draw the free body diagram for the whole structure. Okay, then you indicate the action and the reaction force acting on what the whole structure. Then you write the equilibrium equations for the whole structure. Then from there we can continue to solve for the forces in each of the members. So I'll go ahead and then draw the free body diagram here. So that will be of this form. Okay. Body diagram here. So I'm going to indicate the forces acting on it. I have one in this direction. I have one here also. Then I'll have two reaction forces here. And then I'll have two reaction forces here. And then I'll have one reaction force here in the y-axis direction. Okay. So let me kind of write down the value. So this I have what? The 3 kilonewton. And then this I have, let me this side to be EY. And then this side is 10 kilonewton. And this side, let me make this point, let me make this side AX and then AY. So before I continue, let me name the points. This is point A, this is point B, this is point D, this is point C, and then point E. Okay, so this will be the free body diagram for this system. Okay, I'm going to explain why we have two reaction forces here and then we have a single reaction force here. Okay, so when you take this is a pivot. Okay, and pivots or uh, pin connections. Okay, pin joints allows what or provides pin joints provides what reaction in both what the x and then the y axis direction. Okay, because when you try to move this object here, let's say in this direction, you try to push this structure here in this direction, there will be a force that will act in this direction to prevent it from moving. Same way, if you try to push it down, there will be a force that will act in this direction to prevent it from what pushing. Because you know from Newton's third law of motion, actions and reactions what are equal and then opposite. So the same thing that's happening here. So you see that what due to these reactions here, it will prevent this pin what from moving. It will become what a fixed point, because any action force that what you will act on it, there will be an equal what a reaction force acting on it. So therefore it will become what very rigid here. But when you consider this point here, it is a roller. Okay, that's like it allows free movement of this structure both forward and then backward direction. So therefore there are no reactions in the x-axis direction. But when you try to push this down here, there will be a reaction in this direction to prevent it from moving down here. So you see that what it will uh it will act, or it will provide what a reaction in the what in the x, so in the y-axis direction, but there will be no reaction in the what the x-axis direction. So that's how can you have only a single reaction force here. Okay, so with that understanding, let's go ahead. So now that you've drawn the free body diagram, you are going to write equilibrium equations for this structure. Okay, so the equilibrium equations are, the first one is some of the forces in the x-axis direction should be equal to 0, and then some of the forces in the y-axis should also be equal to 0, and then some of the moments. Some of the moments about a point, in this case the point is A, should be equal to 0. So you are going to write equilibrium equations for this structure and then solve them to get the unknowns. Okay, so we are taking the moment about the point A. Okay, because that's where the point is. Okay, so the point A is a fixed point, so we take the moment about what point A. We can't take the moment about this point A because it is movable. Okay, so the first equilibrium equation will be sign of forces in the x direction. So the first force in the x direction is the ax, and then the second is what, the 3 kilonewton, it is negative, so that will be minus 3 kilonewton. Okay, this is because it is acting in the direction opposite to what, to the positive x axis, so it will be negative. So let me just make it minus 3 kilonewton. Okay, so this should be equal to what, 0. And then let's write for the y also. So sum of forces in the y direction, that will be ay, and then minus the 10 kilonewton because it is acting downwards, and then plus what, ey, which is positive because it is acting upwards, that's in the direction of what, the positive y-axis direction. So all this should be equal to what, 0. So after this, let's write the equation for the moment. So sum of moments about point A. So we're going to take the moment of for each of what, the forces here. So we first consider this force here. So the force 10 kilonewton, the moment will be is the force times for the perpendicular distance. So now let's come back to this figure. So this is the 10 kilonewton here. So what will be its perpendicular distance? That will be the shortest distance from this point to this point, and that's giving us what, this 3 plus this 3, so that will be 6. But the moment will be a clockwise moment, so it will be negative, okay, because this point is here and this force is here. So when it acts, it will turn this system in this direction, so that will be what, a clockwise moment, so it will be negative. So that will be minus what, 6 times the force 10. Okay, so the 6 is the perpendicular distance, and then the 10 is what, the force. Okay, so now let's continue. So let's look at the moment for this force also. So that will be the force times for the perpendicular distance, but this guy will cause a clockwise moment, so it will be what, positive. So that will be plus what, the perpendicular distance will be 3 plus 3 plus 3 plus 3, so that will be what, 12. So that will be 12 times what, ey. Okay, and then let's look at the last one. The last one also cause an anti-clockwise moment, so that will be also what, that will also be a positive moment. So the perpendicular distance will be this distance from here. Okay, that will be this distance here, and that's given to be what, 4 millimeters. Okay, so the perpendicular distance is what, 4 millimeters, so that will be what, 3 times 4. All this should be equal to what, 0. Okay, so now after getting the equilibrium equations, then we have to solve them for the unknown values. So let's go ahead and solve it. So now, looking at this, we can first of all solve for the ax value, right? Because ax equals what, as minus 3 kilonewton equals what, 0. So we get what, the as will be equal to what, 3 kilonewton. So that's the value of what, ax. So let me write this here. So ax equals what, 3 kilonewton. And then so let's go ahead and solve for the remaining. So looking at this, when I take this equation, I can't solve for it because there are two unknowns here. When I take this, I can solve for it because there's just a single unknown. So let's solve this. So this will give me minus 60 plus 12 ey plus 12 ey plus what, 12. This should be equal to what, 0. So I'm going to add the minus 60 and then plus 12. So minus 60 plus 12, that gives me minus 48. So that will be minus 48 plus 12 ey. This should be equal to what, 0. So I'll take the minus 48 to the right hand side. So I get what, 12. I get 12 ey to be equal to what, 48. So I can then divide both sides by 12. Divide both sides by what, 12. So let's see what I'll get at the end. So at the end, I'll get ey to be equal to what. So I get ey to be equal to 4 kilonewton. So that's the value of what, ey. So let me kind of write it down. So ey was 4 kilonewton. Okay, so now that we've gotten ey, we can come and substitute into this equation that we have here, then you solve for what, ay. So now let's go ahead and do that one also. So let me clean this part here. Alright, so we know that what, the sum of the forces in the y direction, you know that ay minus 10 kilonewton plus what, ey. I know ey is now 4 kilonewton. Okay, should be equal to what? 0. So 10 kilonewton minus 10 kilonewton plus 4 kilonewton, that what? Minus 6. So AY minus 6 kilonewton should be equal to what? 0. So now let's make AY the subject. So we take the minus 6 kilonewton to the right hand side. So that will be AY will be equal to what? 6 kilonewton. So that will be the value of what? AY. So let's write that one also here. So you got AY to be equal to 6 kilonewton. So that's the value of what? AY. So now that you've gotten the unknowns here, you go ahead and then calculate for the forces in each of the what? Each of the members. And we are applying methods of joint here. So you are going to draw the figure for each of the joints, then you calculate the force acting on what? Each one of them. So let's go ahead and do this. Okay, so let me bring back the question. Okay, let me clean this. Alright, so we got AY is hiding. Okay, so you got AY to be equal to 6 kilonewton. Okay. So before you continue solving, let's take a look at this. So we are going to consider each of the truss members to be in tension. Okay, if I say that they are in tension, that means what? They are moving away from the joint. Okay, so if they are moving in this direction, that's tension. So I have another joint here, and then the members are moving away. That's the force is acting in this direction. That means what? It is in tension. So tension force pulls away from what? The joint. But if you have a joint, and then the force is pushing towards the joint, that means what? It is in what? It is in compression. Okay, it is in compression. So that will be something like this. And if you get a negative value for a force, that means it is in compression. And then if you get a positive value, that means what? It is in tension. Okay, so first of all, for us to continue this question, you are going to consider each of the forces to be in what? In tension. Okay, so if after solving for it and you get the answer to be negative, that means it was actually in what? In compression. So you just come and redraw your truss a truss diagram. Okay, so looking at this, okay, you see that you are considering each of them to be in what? In tension, except the reaction forces. Okay, so you just consider this, the forces in the truss here. So you see that this is in tension, this is also in tension, this is also in tension. So they are all considered to be in tension. So if after the calculation then you find out that some of them were negative, then that will tell you that what? It was actually what? In compression. Then you can make changes to it. So with this knowledge, let's continue with the solution. Okay, right, so now let's continue. So now I'm going to apply the method of joints here. Okay, so you are going to consider each of the joints, then you calculate what? The force acting in the truss member, okay, of that joint. Okay, so now let's go ahead. So the first joint I'll take will be the joint A. Okay, for you to be able to know the joint you are going to use, consider the joint which has at least two unknowns. Okay, so consider the joint which has what? At least two unknowns. So looking at this joint here, joint A has these two values, but it doesn't have these two values. That's FAB and then FAC. Looking at this ones too, it has what? Three unknowns. This one too has four unknowns. This one too has three unknowns. This one too has what? Two unknowns. So you can take joint A and then joint E. Okay, since they have what? Two unknowns. But in this case, I'll start with joint A. Okay, you can also try starting with joint A. It will also work. So with joint A, I'm going to draw the joint. Okay, so that'll be, let me draw this here. Okay, so let me indicate that these are the truss members. Okay, so we have one, and then this will be the second one. And then let's indicate the reaction forces. So one is in this direction, and then you have one to be in this direction, right? Okay, but we know this one to be AX, which is what? 3 kilonewtons. Let me write it here. 3 kilonewton, and this one to be what, AY, which is what, 6 kilonewton. So 6 kilonewton. But what to be the value of this? So that will be what, FAC. That's from the force from what, in the truss A to C. So that's what, FAC. So let me name this FAC. And then this one to be what, FAB. That's from this side to this side. So that's what, FAB. So let me name this FAB. Okay, by looking at this, okay, we are going to write equilibrium equations for this joint here. Okay, but you know that what, this is what, a concurrent system of force. Okay, and then this is a concurrent system of force, so there will be no movement here. Okay, we treat it to be in what, in equilibrium. So if it is in equilibrium, then that's like the sum of the forces in the x direction will be zero. The sum of the forces in the y direction will also be what, will be zero. So we are going to write equilibrium equation for this. But in this case, there will be no movement. Okay, this is because all the forces are acting directly on the point, and then they are acting directly what, away from the point. So these two are acting directly on the point, so there can't be any moment. This one also are acting directly away from it, so there can't be what, any moment. So in this case, we are not going to calculate moment for it. So we are just going to calculate the values for what, that's the sum of the forces in the x, and then the sum of the forces in the y direction. So looking at this, you see that this force is at a certain angle theta. So let's name here theta. Okay, so that tells us that what, the resultant will have what, x and then y component. Okay, so for us to be able to continue, we have to find the x and the y component for FAB. So let's do that. So for this to be easy, let's say you have FAB here, it will have what, x and then y component, right? Okay, it will have what, x and then y component. Okay, so I'll make this side the x component, this side should be the x component, and then this side should be what, the y component. So you are going to find what, the x and the y component of what, FAB. So you see that this angle here, okay, we will have the same angle here. Okay, the same as the angle that we have here. Okay, it's the same as the angle that we have here. But how do you find this angle here? So let's come back to this figure here. So looking at this angle, this is the angle to be theta here. So how do you find this angle here? You know that what, this side is 4 meters, right? It's given to be 4, and then this side too is what, 3. So how do you find this angle theta here? So that will be the tan of theta, what, opposite. So the opposite is 4 over what, adjacent, which is 3. So theta will be equal to what, the tan inverse of what, 4 over what, 3. So let's do that things. So we get the tan inverse of 4 over 3. So that gave me 53.13. So 53.13 degrees. So that would be the angle. So the angle here will be what, 51.13, and it will be the same angle that will be here also. Okay. So this is to tell us that what, the angle that FAB makes with what, the horizontal is what, 53.1. Okay, so theta equals what, 53.1 degrees. So you are going to use this angle to write what, the x and then the y component for what, for the force FAB. So looking at the x component is what, it is what, adjacent, right? So if you want to write for the x component, that would be what, cosine of what, 53.1 equals what, adjacent, that would be what, the x component of what, the hypotenuse, which is what, FAB, right? So the x component will be equal to FAB cosine of what, 53.1, and then therefore the y component will also be what, FAB sine of what, 53.1. So those are the x and then the y component for the force FAB. So now that you know the x and then the y component, you can come back to this and then write the equilibrium equations for this. Okay, so for me to get more space, let me come and write this here. So you got theta to be equal to 53.1. Okay, so for FAB, you got it to be for the x component, you got what, FAB cosine of what, 53.1 53.1, and then the y component, that's for the x, and then the y component, we got what? FAB sine of let me clean this part. Okay, so we got FAB sine of what? 53 53.1 degrees. This is for the what? Y component. Okay, so now let's go ahead and then write the equilibrium equation. So I'm going to write for some of the forces in the x direction and then some of the forces in the what? Y direction. So let's consider the forces in the x direction. This is one of them, this is one, and then this one is also what? One of them. So let's write it. So you have what? 3 kilonewton, that's 3 plus what? FAC plus FAB. What's the x component? That's what? FAB cosine of what? 53.1. So that's FAB cosine of 53.1 degrees. Okay, this should be equal to what? 0. That's what sum of the forces in the x direction. So for the sum of the forces in the right direction, that will be sum of forces in the right direction. So that will be what? This 6 kilonewton here plus this y. By this y is what? FAB sine of what? 53.1. So that will be plus FAB okay, sine of 53.1. So sine of 53.1. This should be equal to what? 0. Okay, so now we are going to consider these two equations that we have here and then look at the one that you can solve for the unknown. So looking at this, the sum of the forces in the x direction, it has what? Two unknowns, but this one has what? It's a single unknown. So that means we can find what? We can find FAB using the second equation. So let's do this. So that's FAB sine of what? 53.1 will be equal to what? Minus 6. I took this 6 to the right hand side. So I'm going to divide by what? Sine of what? 53.1. So that will be divided by sine of 53.1. So divided by sine of what? 53.1. So let's do this and see what we get for FAB. So then FAB will be equal to which value? So let's do this. So that will be minus 6 divided by the sine of 53.1. So this gave me FAB to be minus 7.5029. So let me make this to be minus 7.5 kilonewton. That's what FAB. Okay, so now that we've gotten FAB, we can go ahead and solve for what? FAC. So now let me write FAB here. So FAB was minus 7.5 kilonewton. So now let's come and focus on find what? FAC using the first equation there. So you know that what? 3 plus FAC plus FAB cosine of 53.1 equals what? 0. So now you know what? FAB to be equal to what? Minus 7.5, right? So let's come and substitute. So that will be equal to what? 3 plus FAC minus 7.5 cosine of what? 53.1. This should be equal to what? 0. So let's go ahead and simplify this. So that will be, let's take these ones to the right hand side. So that will be FAC will be equal to what? Minus 7.5 cosine of 53. So that will be minus 7.5 cosine of 53.1. So that will be minus 4.5. So that will be equal to 4.5 minus what? 3, right? Okay, so that will give FA to be equal to what? 4.5 minus what? 3. So that give me what? 1.5. So that will be 1.5 kilo Newton. So therefore FAC equals what? 1.5 kilonewton. So FAC equals what? 1.5 kilonewton. So that's FAC. So now that you've gotten this, let's go and focus on the rest of what? The joints. So let me clean this. Okay, so let's write down the value that you got. So you got FAB to be equal to minus 7.5 kilonewton, and then FAC, you got FAC to be equal to what? 1.5 kilo Newton. Okay, so now let's focus on joint B. Okay, because now you know FAB, so the only unknowns here will be what? FBC and then FBD. So you can focus on joint B. Okay, so now go ahead and then draw my B. Okay, so the point B to be of the form to have this component, one in this direction, one in this direction, and then one also be in this direction. Okay, but looking at these two forces here, okay, this is FAB, this is FAB, and then this is FAC. Okay, so this is FBC rather. Okay, this is FBC, and then this is FBD. Okay, by looking at FAB and then FBC, you see that what it's neither in the vertical or the horizontal form, so that means it will have what component. Okay, to have the x and then the y component. Okay, so now let's indicate the x and then the y component for these two. So for FBC, it have one component in this direction and then have the other one in this direction. So this will be, let me indicate it very well. Okay, so it will have x and then the y component, so this direction and then one in this direction, right? One in this direction. Okay, something like this. This shouldn't confuse. Okay, let me make it this better. Okay, so this will be the x component and then this will be the y component. Okay, for this one also, it will have x and the y component, so this will be the y component, and then to have y component and then x component, so this will be the x component and then this will be the y component. Okay, so you see that what FAB and FBC will have what x and the y component. So for us to be able to continue, you have to find the x and then the y component for these two. So first of all, looking at FAB, okay, this is the angle, right? Theta here. Okay, you know the angle to be what 53 point. That theta is 53.1 degrees. That's from the previous solution that we did. So if you want to write the x component will be what this side, and then this will be what the y component. So the x is what adjacent. So for the x component of FAB, that will be equal to what FAB, right? So that will be cosine of 53.1 equals what cosine of 53.1 equals what adjacent. So that will be x over the hypotenuse, which is what FAB. Okay, but we got FAB to what negative what 7.5, right? So FAB was negative 7.5. So let's keep that in mind. So if I want to make x the subject, this will give me the x component to be what FAB cosine of what 53.1 degrees, right? So this will be the x component. By looking at this, you see that the x component in this case is what moving the direction opposite to what to the x axis, so the x component will be negative. So I'll come and negate this here, so you get what negative FAB cosine of what 53.1. So what are the y component? So the y component, so we have something like this. For the y component, you have what sine of 53.1 degrees will be equal to what opposite, so that what the y over what hypotenuse, that's FAB, right? So the y part will be equal to FAB sine of 53.1 degrees. By looking at this, you see that what the y part is also moving in the direction opposite the positive y axis, so it will also become what negative. Alright, so the y component also becomes what negative. Okay, so we've gotten the x and the y component for FAB. Okay, so let me write this somewhere. Okay, so for FAB, okay, we have what? For the x component, we have what? Minus FAB minus FAB cosine of 53.1 degrees. That's cosine of what? 53.1 degrees. That's for the x part. And then for the y part, we have what? Minus, it's supposed to be FAB. That's what you have, what? Minus FAB sine of what? 53.1 what? Degrees. Okay, so same as for the FBC, so I'm going to find the x and then the y component. Okay, so let me clean this side here. So now we are considering FBC here. Okay, so for FBC, this is the FBC here. So what to be this angle here? Okay, so what to be the value of what? This angle here. Okay, this angle here will be this angle here will be 53.1 degrees. Okay, so same as the angle here. Okay, so let's find the x and then the y components for this. Okay, so we do same for what? FBC. Okay, so we do same for what? FBC. So we consider this angle that is here. So we consider this angle here, and know this angle also be what? 53.1. Okay, so looking at this angle, the x component which is here. Okay, so that's like the angle is over here, something like this, right? So the x component is what? Adjacent. So that will be for the x component, you have what? Cosine of what? 53.1 degrees equals what? The adjacent, which is what? X over what? Hypotenuse, which is what? FBC. So the x component will be equal to, that's the x component will be equal to what? FBC cosine of what? 53.1 degrees. And then the y component, that's for the y component. Let's solve for that one too. That one to be, it is opposite, so that will be sine of what? The angle 53.1 degrees will be equal to what? Opposite. So that's the y over what? The hypotenuse. That's what? FBC. So the y part will be FBC sine of what? 53.1 degrees. But in this case, the y part is moving the direction opposite to the positive y axis, so it becomes what? Negative. Okay, so now that we have this, let's kind of write them down. Okay, so let me clean this side here. Okay, so for FBC for the x component, I got what? FBC cosine of 53.1 degrees, and then for the y component, I got minus what? FBC sine of what? 53.1 degrees. Okay, so now that we know the x and the y component for all of them, let's go ahead and then simplify this. So I'm going to take away this. So now what you are going to do is that you are going to sum the forces in the x direction and the forces in the y direction, then you solve for the missing ones. So for the forces in the x direction, that's some of the forces in the x direction. Let's consider this. So you have what? When you take FAB, it has what? S component, and this is it. So that's minus FAB cosine of what? 53.1 degrees. And then this one, FBC has S components. That's also plus what? FBC cosine of what? 53.1. Cosine of 53.1 plus what? FBD. Okay, so plus FBD. This should be equal to what? 0. Okay, so for the sum of forces in the y axis direction, to the sum of forces in the y axis direction. So FAB has a y component of what? Minus FAB sine of what? 53.1 degrees, and then FBC also has a y component of negative FBC sine of what? 53.1. sine of 53.1 degrees. So this will also be equal to what? 0. So we are going to solve for this. But from the previous solution, we know that what FAB equals what minus 7.5. So you're going to substitute FAB into this wherever it is missing and substitute it there. Okay, so now let's go ahead and do this. So looking at these two equations, okay, let's kind of substitute the FAB into it. So this one here, I'm going to clean it. So this one here, we got, okay, let me make it clear. So I'm going to rewrite this here. So some of the forces in the F direction, that's minus FAB cosine of what 53.1, but FAB is also what negative, so they will cancel as well. At the end I have what 7.5 cosine of what 53.1 degrees, and then plus what FBC cosine of what 53.1 degrees plus what FBD. This should be equal to what 0. And then for some of the forces in the y-axis direction too, okay, let me use different color to write this. So some of the forces in the y-axis too, that will be minus FAB. So you know FAB to be 7.5, so it to therefore become 7.5 sine of 53.1 degrees minus what FBC sine of what 53.1 sine of 53.1 degrees. This will be equal to what 0. So now that we have these two equations, we look at the one that we can solve first. So looking at the first one, it has what two unknowns, which is FBD and then FBC, so we can't solve for this. But this one has only one unknown, which is what FBC. So let's go ahead and then solve for that one. So I'll go ahead and then solve for FBC here. So now let's make FBC the subject. Okay, so I'll take this guy to the right hand side. So that'll be minus FBC sine of what 53.1 degrees will be equal to what minus 7.5 sine of what 53.1 degrees. Right, so I can cancel out the 53.1, so that'll be divided by what minus, that will divide by minus sine of what 53.1 degrees divided by minus sine of what 53.1 degrees. So I can then cancel out. So then I'll get what my FBC to be equal to what 7.5. So now that you have FBC to be 7.5, then we can find what FBD. So FBC equals what 7.5. So I have that one written down. So now let's come and focus on the second, so on the first equation rather. So on the first equation, have what 7.5 cosine of what 53.1 cosine of 53.1 degrees plus what FBC. But I know FBC is what 7.5, so that was plus 7.5 cosine of 53.1 degrees plus what FBD. Okay, so this is equal to 0. So let's simplify this. So first of all, let's take 7.5 cosine of what 53.1. So that will give me 4.5.02. So let's make it 4.5. Okay, so plus what 7.5 cosine of what 53.1, the same thing. So that'll be plus what 4.5 again plus what FBD. So this should be equal to what 0. So let's make FB the subject. So this 4.5 plus 4.5 gives me 9.0 plus FBD should be equal to what 0. So I'll therefore get my FBD to be equal to what negative 9.0 kilonewton. So now you know FBC and then you know FBD also. So now FBD was negative 9.0 kilonewton. So now that you've gotten FBD and FBC, let's go ahead and then solve for the forces in the next joint. So let's pick another joint and then let's solve for the forces in that one also. Okay, so I'm going to clean all of this also. All right, so back to this side. So let's write down the answers we got. Okay, so we solved for what? FBC. Okay, so we got FBC to be equal to minus 7.5 kilonewton. That, sorry, it was 7.5 kilonewton. We got FBC to be 7.5 kilonewton, and then FBD to be equal to what? Minus 9.0 kilonewton. Okay, so now that you know this, let's focus on the next joint. So the next joint I'm going to pick is I'll pick joint E. Okay, when I pick joint E here, I'll pick joint E because it also has what, two unknowns here. So I'll pick joint E and then focus on it. So I'm going to draw joint E. So let's look at this. So let me indicate the joint here, and then let me draw the component. So we have one in this direction, and then we have one in this direction also. Then we have another one in this direction also. All right. So this value was 4 kilonewton, and then this is FCE, and then this is FDE. Okay, by looking at this, you see that what FDE has both X and then Y components. Okay, FDE has what, both X and then the Y component. So we have to solve for the X and then the Y component. Okay, so okay, I want to extend FDE. Okay, so that it will be easy for me. So I'm going to extend this. I'm going to make it a little bit longer. Okay, so something like this. So now let me indicate the X and then the Y component. So it will have S component and then it will have what, a Y component. Okay, so you see that what, the S component will be negative because it will move in the direction against what, the positive X axis. So this will be negative, and then this will be what, positive. Okay, so now let's find the S and then the Y components of this FDE. Okay, by looking at FDE, you see that what, it makes an angle of what, 53.1 degrees. That's the angle here. That's the angle here. Okay, that's also about 53.1 degrees. Okay, when you take this side to be 4 and then this side to be 3, and then you take the tan inverse of this angle, you get theta to be equal to what, 53.1 degrees. Okay, all right, so now let's go ahead. So from here, what I'll do next is that I'm going to find the S and then the Y component of what, FDE. That will be the main focus here. So when you consider FDE, okay, so what will be the S component? So that will be, let's take cosine of this angle. Okay, so cosine of what, theta, will be the X over what, the hypotenuse, which is what, FDE. Right, so the S component will be equal to what, negative FDE cosine of what, theta. Right, but I know theta is what, 53.1, so that'll be 53. Let me write this one. That's cosine of what, 53.1 degrees. So let's see for the Y part also. So the Y part will become that's FDE sine of what, 53.1 degrees. Should that be the Y part also? So now that you've gotten the X and the Y part of what, the FDE, let's go ahead and then finish up. Okay, so let's write some of the forces in the X direction and some of the forces in the Y direction. So for the some of the forces in the X direction, okay, so first of all, we have what, negative FDE cosine of what, 53.1 degrees, and then minus what, FCE, it is also negative, so minus what, FCE. Okay, so those are the S components, so that's, this should be equal to what, 0. So let's do for the Y component, some of forces in the Y component. So that will be the 4 kilonewton plus the y component of FD. Okay, so plus the y component of the FD. So that would be plus what? FDE sine of what? 53.1. Sine of 53.1 degree. This will also be equal to what? 0. Okay, so now let's continue. Okay, so considering these two equations, you can see that you can easily find FD here since it is the only unknown here. But here you have two unknowns here, so you can't solve this. So you can solve the second one. So let's make FDE the subject. So FDE sine of what? 53.1 degrees would be equal to what? Minus 4. So let's divide both sides by our sine of 53.1 degrees. So divided by sine of what? 53.1 degrees. So let's divide both sides. So minus 4 divided by the sine of what? 53.1 degrees. That gives me FDE to be equal to what? Minus 5.00197. So let's make FDE to be equal to what? Minus 5 kilonewton. So that's the value of what? FDE. So let me write this somewhere. So you got FDE to be equal to minus 5 kilonewton. So now that you know FDE, let's kind of substitute into the first equation, then we solve for what? FCE. Okay, so I'll make FCE the subject here. So that'll be, let me write this first. So that'll be minus FDE cosine of what? 53.1 degrees minus what? FCE should be equal to what? 0. So I want to make FCE the subject, right? So that'll be minus FCE should be equal to what? FDE cosine of what? 53.1 degrees. So now let's come and substitute FD here. So that would be minus FCA should be equal to what? Minus 5 cosine of what? 53.1 degrees. So let divide both side by the negative by the negative. So let's see what we get for what? FCE. So FCE will be equal to what? 5 cosine of 53.1 degrees. So that gives me FCE to be equal to what? 3 kilonewton. So that's the value for what? FCE also. Okay, so now let's kind of write down our values. Okay, so let me clean all this. Let me clean all this here. Okay, so let's come back to this side. Okay, so now let's write down the values that we got. We got FDE to be equal to what? Minus 5 kilonewton. And then FCE to be equal to 3 kilonewton. Okay, so now we've done three of the joints. Okay, so we've done for joint A, joint B, we've done for joint E. So now let's do for joint D. So I'll go ahead and then draw joint D only. So let me draw joint D here. So it will be on the form something like this. Okay, so in this case we are considering all the members to be in tension. Okay, so I'll draw it this way. Okay, then it will have another one to be in this direction. Okay, alright, so that's for the joint D. Okay, so now let's indicate them. So this will be FDE, this will be FBD, and then this will be FCD. Alright, so let's go ahead. So looking at FDE here, okay, looking at FDE here, you see that what it will have both X and then the Y component, right? But I know FD is what? Negative 5 Newton. Okay, we know that one already. So the main thing we need here is to find what the S and the Y components of what this force here. So let me indicate this. Okay, so this will be the Y component and then this will be the S component. Okay, and then for this one also, it will also have what X and then the Y component. So let me indicate that one also. Okay, so this will be the x component, and then this will be the what? The y component. So let me write them down. X, this is the x component, this is the y, this one, so this is the x, this is the y. Okay, so from here I'm going to write all the equations for some of the forces in the x axis direction and some of the forces in the y axis direction. So before then, let's write down the force component for the FD and then FCD. Okay, so when you look at FD, to have what both x and then the y component, but the angle it makes here is what theta, which is what, theta equals what, 53.1 degrees, right? So the x component, which is what adjacent, that would be cosine of what, 53.1 degrees, will be the x over what, FDE, right? So the x component will be equal to what, FDE, that be that be FDE cosine of what, 53.1 degrees, and then the y component will be negative because it's going the direction opposite to the positive y axis, so that will be negative FDE sine of what, 53.1 degrees. So that will be the x and the y component for the FDE. So let's do same for the FCD also. So for the FCD, okay, the angle it makes with what will be this theta here. Okay, and that's also what, 53.1 degrees. Okay, because of this 3 and then the 4 that we have here. If you take tan inverse of 4 over 3, it will give you the angle theta, which is what, 53.1. Okay, so now let's find the x and then the y component of what, FCD. So for the x component, that will be cosine of what, 53.1 degrees equals what, the x component of what, hypotenuse, which is what, FCD. Okay, so the x component will be equal to what, FCD times cosine of what, 53.1 degrees. But in this case, you know that what, the x component is moving the direction opposite to the positive x axis, so it becomes what, negative, and then the y part will also be negative FCD sine of what, 53.1 degrees, since it is also moving in the direction opposite to the positive y axis direction. So now that we've gotten the x and the y component, let's come and then sum them. Okay, so let's not forget FD. We know FD to be equal to what, minus 5 kilonewton. Okay, so we know FDE to be FDE equals what, minus 5 kilonewton. Okay, we know this already. So now let's come and write the equations. So I write for some of forces in the x direction. So for the x direction, we have FDE cosine of what, 53.1. So we know FDE to be what, minus 5 kilonewtons. So let me write this one. So that be minus 5 cosine of what, 53.1 degrees. Okay, plus what's the other x component? So that's minus FCD cosine of what, 53.1 degrees, and then plus what, FBD that we have here. But you know FBD is moving the direction opposite to the negative x axis direction, so it will be what, negative. So that will be minus what, FBD. That's minus what, FBD. Okay, FBD. So this should be equal to what, 0. Okay, so now let's write for the x component also. So for the x component, you have to, oh, so that's for the x components. Let's write for the y components. For the y components, we have two y components here. So the first one was sum of forces in the y component. That's negative FDE. So that's what, negative 5. But since they are negative, so we get what, 5. That's what, 5 sine of what, 53.1 degrees. Okay, minus this, right? Okay, so minus what, FCD sine of what, 53.1 degrees. This should be equal to what, 0. So those are the some of the forces in the x and in the y direction. So now that we have this, let's focus on solving for the unknown values. So considering these two equations that we have here, see from the first one, I have FCD and then FBD as the unknown, but here we have just FCD as the unknown. So let's go ahead and solve for FCD. So I'll take 5 sine of 53.1 to the right hand side, so that will be minus FCD sine of what 53.1 degrees should be equal to what minus 5 sine of what 53.1 degrees. So I can cancel out the minus sine of what 53.1, okay, divided by what minus sine of what 53.1 degrees. So this will cancel out, this will cancel out, so then we get what FCD to be equal to what 5 kilonewton. Okay, so now you know FCD to be equal to what 5 kilonewton. So now that you know FCD, let's go ahead and solve for what FBD. Okay, so let's solve for FBD. So we take the first equation and then substitute FCD into it. So that's okay. So let me use different color. So that'll be minus 5 cosine of what 53.1 degrees. Okay, minus what FCD. So that's minus 5 cosine of what 53.1 degrees minus what FBD is equals 0, right? So you can take these ones to the right hand side. So we get what minus FBD to be equal to what 5 cosine of what 53.1 degrees. Okay, plus what 5 cosine of what 53.1 degrees. So let's simplify these two and then let's see. Okay, so let's do 5 cosine of what 53.1 plus 5 cosine of 53.1 degrees. So that gives me 6. So I'll get minus FBD to be equal to 6. So I divide both sides by the negative one. So then I'll get what FBD to be equal to what minus 6 kilonewton. So we now know that what FBD equals what minus 6 kilonewton. Right. So let's kind of write down our answers. Okay, so now that we got in this, let's kind of write down our answers. So I'll go ahead and clean this. Let me clean the unwanted ones here. Okay, we don't need all this now. Okay, so let's write down the values that we've gotten. So you got what FCD. Then write this here. FCD was 5 kilonewton. And then FBD was minus 6 kilonewton. So you realize that what is left with what joint C. Okay, it's left with what joint C. So let's draw joint C and let's see what happens here. So I'm going to draw joint C. Okay, so joint C, this is it. So it has one component in this direction. It has another in this direction. They are all in tension. Okay, so it has this also in this direction and has one in this direction. Okay, so now let's name them. So this is FCE. This is FCE. This is FCD. And then this one is FBC. And then this is what FAC. Okay, so the when you draw the joint C here, okay, so you see that what you have what FBC, right? So FBC, but we already found for FBC, which is 7.5. So FBC equals what 7.5, and then FCD, need to find FCD. Okay, so FCD, let's look at here. So you got FCD to be what 5 kilonewton. Now we have it already. And then the next one we need is what FAC. So FAC also, we have FAC to be what 1.5 kilonewton. And then the last one we need is what FCE. And no, FCE was gotten to be what 3 kilonewton. So those will be the forces in the members what at joint what C. Okay, so this is how to apply the method of joints.